Good morning, friends. Today we are going to start the book of quantum mechanics written by David J. Griffith. So, we will solve this book, we will understand what are the topics in this book in subsequent videos. So, basically, this book is about introduction to the quantum mechanics, and we will first of all we will see what are the topics covered in the book. So basically this book is formulated in two parts. First part is the theory part, basically is about what the quantum mechanics is. So in this 5 or 6 chapter, the author have completed or described the basic idea about the quantum mechanics. So the first part is the theory part, and the second part will be of the application of the theory, which are the based on these applications. So we will cover one by one all the chapter. So in the very first chapter of this book, they have explained about the wave functions. The wave functions, what are the wave functions? So basically wave functions are the solution of Schrodinger equation. So in this book the Schrodinger equation is stated and the statistical interpretation of the wave function is given. For example, psi has no useful meaning, but the psi star psi, which is the probability density, so which have the physical meaning. So we will discuss about some of the topics of the probability as well, and then we will discuss what is the normalization condition, and then we will discuss the momentum of operator and about the uncertainty principle. This chapter, the second chapter, is about time independent Schrodinger equation. In this case, stationary states are defined, and 3 or 4 examples. One is the infinite square well, another one is harmonic oscillator, another one is free particle, delta function, and finite square well are given in the chapter. Okay. Similarly, we will discuss one by one all these chapters. Okay, so let's start the chapter number 1. What is given in that? Yeah, from there on, यहाँ से अपना part first of the theory part start होता है. The chapter name is the wave function. What he have explained is the Schrodinger equation. What is given in the para 1 is that let us imagine, अपन मान के चलते हैं कि अपने पास एक पार्टिकल है जिसका मास m है, जो कि x एक्सिस पे मूव कर रहा है. उसके ऊपर कोई फोर्स लग रहा है. वी हैव स्टेटेड द फोर्स एज f. सो फर्स्ट ऑफ ऑल, इफ क्लासिकल मैकेनिक्स इस प्रॉब्लम को किस तरह से डील करता है, तो उसके बारे में बताया कि जो क्लासिकल मैकेनिक्स है उसमें क्या होता है. सबसे पहले अपन किसी पार्टिकल का पोजीशन पता करते हैं किसी टाइम t के ऊपर. उसके बाद में अपन उसकी वेलोसिटी पता करते हैं बाय डिफ्रेंशिएटिंग द पोजीशन विद रेस्पेक्ट टू टाइम. सिमिलरली अपन मोमेंटम पता कर सकते हैं. मोमेंटम इज इक्वल टू मास टाइम्स वेलोसिटी. एंड अपन काइनेटिक एनर्जी पता कर सकते हैं 1/2 mv² के फॉर्मूला से. सो इफ़ वी नो द पोजीशन विद रेस्पेक्ट टू टाइम, position at any time t, by differentiating we can find out velocity. By multiplying with mass we can find out momentum, and by using this kinetic energy operator 1/2 mv², you can find out the kinetic energy as well. But the main problem is how to find out xt, right? Once we have the x of t, then we can find out all these quantities. But first of all we have to get this xt as well. So इसको कैसे निकालेंगे अपन? तो उसके लिए अपन यूज करेंगे न्यूटन सेकेंड लॉ, विच इज फोर्स इक्वल टू मास टाइम्स एक्सीलरेशन, right? And acceleration is given by d square x by dt square as given in that case. And for the conservative system, force is equal to minus del v by del x. This is the formula. So we equate this equation and this equation. What we get is md square x by dt square equal to minus del v by del x. This is the differential equation. We can solve this differential equation. If we know the initial conditions, that means at t equal to 0, position and velocity, then we can find out the solution of this equation. And the solution of this equation will be x of t, right? And then we can find out all these parameters. This is what the classical mechanical idea about the problem. Now comes to the quantum mechanics. Quantum mechanics deal the same problem as different very very differently. What happens in that case, जैसे कि अपन ने क्लासिकल मैकेनिक्स में एक्स ऑफ टी फाइंड आउट किया यूजिंग द न्यूटन्स इक्वेशन, इसके अंदर अपन वेव फंक्शन फाइंड आउट करेंगे. क्वांटम मैकेनिक्स में अपना मेन काम क्या होगा, वेव फंक्शन को पता करना. और वेव फंक्शन जो है वो क्या होता है, सॉल्यूशन होता है. फॉर एग्जांपल एक्स ऑफ टी क्या था, सॉल्यूशन था इस डिफरेंशियल इक्वेशन का. उसी तरह से अपना जो वेव फंक्शन है वो सॉल्यूशन होगा किसका, श्रोडिंजर इक्वेशन का. एंड श्रोडिंजर इक्वेशन इज गिवन बाय दिस स्टेटमेंट, I h cross del psi by del t equal to minus h cross square by 2m del square psi upon del x square plus v of psi, where iota you know under root minus I, h cross you know h upon 2 pi, h is the Planck constant, del psi by del t is the derivative of wave function with respect to time, is equal to minus h cross square by 2m. M is the mass of the particle, this is the double derivative, and v is the potential, and psi is the wave function. Got the point? Thank you.